Hello and welcome to the Science and Play channel, the only channel that allows you to learn, play, have fun and eat, and still learn the science behind every activity. Today we have a very busy table, and to let you know, today we are not just a science teacher and science students affair. Today we are engineers. We are going to build a bridge, construct a bridge. So please don't just call us science teacher and science student today. Today we are engineers, and I'm sure you also want to be an engineer. Okay, we are going to build or construct a paper bridge with our materials. We'll be learning how shape and the ability of an object to be able to bend plays a very key role in constructing bridges. We have here the basic materials. Will be your blocks. You can use book stack, but you need your paper to build your bridge, and the items that will hold it. So items that you put on your bridge can be anything. We can use this Ultimate Prime. We'll put keys. I think we would add some coins to it too. Yes, a pack of coins. Any item to see if our bridge is strong enough to hold any item or object. Then we can tell that, yes, indeed, we are the best engineers. You can also become a paper engineer like us and learn about how shape plays a role in this activity. So pay attention and follow closely. Kofi will build his bridge stand with his blocks. Then Kakra will build a book stack, and then we can start with the activity. So let's clear up the table a little. Yes, you want to do the books, that's fine. Kakra, come and build the blocks. So this block is going to be more of the pillar. And so we need it very high. Yes, we need our pillars to be high, strong, to hold our So help us build it.
That's my book. What's a dial?
The construction of our pillars with the blocks is done, and so we are going to clear the table to make room for the construction of the bridge. Our book stack as our pillars to see which of our engineers will be the best. Okay. Yes. Let's see. Now I'm going to instruct our engineers. Now, engineers, put a piece of paper on your pillars. Hurry up. Let's see what work you are going to do. Yes, straighten it a bit. Okay. Now, put any object, just one object on yours. Kofi, do yours. Put it on yours. Oh, it just broke down. Imagine a car on this bridge. Oh no! What kind of bad engineers do I have in here? Okay, now we are going to change the shape of this paper. What we are going to do now is to turn it this way. In between. Kofi, do yours. Turn it in between. I should do it for you. That's fine. Kofi always wants me to do it for him. Now, drop your items. You can drop a key. Okay. First item, our bridge is still standing. Second item, oh no, we just broke our bridge. Kofi, let's see if yours will stand. At least use this and let's see. Drop this key on your bridge, paper bridge. Let's see what engineers have. Oh, coffee didn't even break. It just went on the side of it and dropped. So this is how our cars are going to fall. Let me drop it in the middle and see. Oh, squish! So now, engineers, we are going to go through a very thorough work because I don't like this kind of shabby work you guys are doing. Let's fold our paper to see if the shape of the paper would allow these objects to stay longer or stand on it without collapsing our bridge. So let's try this and see. Let's fold this way. You do this, fold it to the front, backwards, back, forth, back, forth, back, forth. Come and do this here. Come and do this here. And you do one for Kofi. Kofi, you do yours by yourself. Are you going to do it by yourself? No, everything. Kafra, just do it.
Hello.
Key concepts here are gravity, weight, engineering, and physics. That is what we are doing here today. Note that selecting the right materials and the shape in a way to make them stronger is very important. Kofi has his folded bridge now. Kofi, drop your triangle on your bridge and let's see what happens. Okay, slowly. Yes, the cars will be moving slowly, so don't throw it. Just put it on it. Don't throw, Kofi. Put it in the middle. Put it in the middle. Okay. Where are the keys? That's quite heavy. I'm going to put it on it. Should I? Why are you running away?
It's not falling.
It's not falling because you're a good engineer. And this is how we are going to get all our contracts. Let's put our auto on. It's not falling. See, our bridge hasn't collapsed yet. Guys, you need to really employ us. The best engineers. Let's add this. Oh. Where is the pack of coin? We have this pack of coin we are going to add. This is quite heavy. 50 pieces of coins in this. Let's put it here. Hooray! Let's get our track to go over this. Oh, but Kofi, let me use your track.
Come over here.
Go over it. Good job! Okay, let's see if Kakra is also a good engineer, just like Kofi did. Let's see what happens with Kakra. What we just saw is to let you know that even though it's the same paper, we are wondering why did the items drop with just an object when the paper was just flat. And now when we folded it between, it slipped by the side when Kofi did his, and also Kakra with just two objects, it collapsed. And now the same paper we see here, when it was folded, is giving us different results. Very strong and steady bridge, which is not falling over. With even our Optimus Prime car riding over it, it still didn't fall. And so this should tell you that, as I mentioned earlier from the start, the shape and the material makes a lot of difference. It plays a role in designing a steady bridge or any structure. And so you need to pay attention to them. The piece of paper will be easy if you try to fold it. It's easily foldable. How hard it is or bend is called the bending stiffness. If you fold it in the same material we had earlier, when we had it flat on the block or the book stack, when we turned it and folded it just in one piece into it was the same piece of paper. But after folding it over and over and putting it on, realize that this was steady. The same material, but the shape now was making the difference. The shape affects it, both bending, stiffness, and it's important to engineers. If you don't, a bridge could sag under the weight of a car, any vehicle, and collapse eventually. So it is important you take note of the shape and the material using to construct a steady structure. We can try to look at this with things around us. This is not an abstract learning. This is supposed to be fun. This is supposed to help us to be able to explain the little things around us. So we are going to look at it from the basic materials around us. And as kids, we go to school, we do have our chairs. So let's take a look at this. So let's not go far. Let's look at something basic around us. We are looking at this chair. We are going to look at the stand for the chair. Why do we not have a pointed base here, but rather a broader base? It means the shape is important to prevent you from falling, for this chair from collapsing. And so you have this broad base to be able to allow it to stand firmly, then so that you can sit on it or sleep on it without falling. And so it is very important the kind of material. This is hard plastic. And also the shape of the stand is very important so that you don't fall. If we try to take one out and see, can this hold it? Can this hold it? No. So today your engineers have just taught you that the basic thing is about the shape and the material for building steady structures. Thank you. See you again soon. Don't forget to subscribe to our page.